Hello and welcome to another session. In today's lecture, we are going to briefly discuss public key certification, which is also known as digital certificate. This topic is strongly related with the digital signature, which we covered in the previous lecture. So let us see what is a public key certificate. A brief agenda for today's lecture. We are going to explain public key certificate, and then why we actually need public key certification. What were the problems with the digital signature, or what are the limitations of the digital signature? And finally, X.509 certificate, which is the backbone of a digital certification. So let us start with public key certification. We have studied two concepts, actually three concepts: cryptography, hash function, and digital signature. And now we have another construct by which we can scale up the use of message signing. And that is in the form of digital certificates, or simply certificate or public key certificates. Public key certification is another important application of digital security, network security, information security, or you can say it is an application of a digital signature or a component of a digital signature. That is certifying that the public key, as the name indicate, public key certification, that the public key actually belongs to a specific entity, whether it is the public key of A, whether it is the public key of B or C. How you will make sure that it is actually the key of A, not B? Because anyone could claim that this is his or her public key. So how actually you will make sure that the public key belongs to a specific entity, a specific process, a specific person, a specific machine, a specific browser, etc. So certificates are created for this purpose, in actually to link a public key to a particular individual, process, machine, node, etc. That is the basic principle objective of certificates. The advantage of having certificate is that it allows us to verify that a public key is truly associated with a particular individual. Remember the problem? It is very difficult to trust on individuals who are actually involved in the communication. So in order to establish the trust between the entities, we need a certification, and for that we need an authority, which is known as certificate authority, or CA in short. It is actually a trusted entity that will handle this digital certification. Okay, so it could be a government agency, it could be a financial institution, it could be a broker, it could be a third party trusted entity, and so on. Depends. And in a true sense, or to be more technical, this CA is actually a small portion of the infrastructure, and the big infrastructure is actually known as PKI, which stands for Public Key Infrastructure. This is the well-known infrastructure which is responsible for the key sharing among parties, among different communicating entities. And this CA is actually, you can say, a small part of this big or this whole infrastructure. And that is actually in place to handle certificates on a larger scale. So if we have a digital certificate for the sender, we can easily check with this certifying authority to ensure that the public key for the sender is legitimate. And one well-known example of CA is VeriSign. There are other examples as well. For example, Komodo, Symantec, and GoDaddy and Thauti, etc. So plenty of CAs are available, but the most common one is VeriSign. Okay, next point is that instead of providing public keys, it's better to provide a certificate. But how the user will acquire a public certificate? The process is very simple. A user need to present his or her public key to the authority in a secure manner and then would be able to obtain a certificate. And then the user can publish this certificate. Instead of publishing the public key, the user will actually publish this public certificate. Now, anyone needing or anyone in need of the user public key can obtain the certificate very easily and then verify this with whether it is a valid certificate or not. Okay, so that is possible with the help of a CA. Moving forward, the question is that why we actually need digital certificate, or in other words, you can say what were the problems with the digital signature. Well, in the case of the digital signature, it might be possible that someone had falsified the keys being used to sign the message, and that the keys did not actually belong to the original sender. Well, to make things simple, let us consider an example, a problem actually. Let's consider that Alice and Bob, they want to communicate with one another. In this example, Alice has a pizza house and she sell pizza, and Bob want a pizza to be delivered to at his home address. This problem is known as a pizza prank. Okay, so Alice is in the pizza delivery business and she accepts order over the internet. Now, Bob, who is actually a pizza lover, sends Alice a plain text message that include his home address and also the pizza that he wants. Now, in this message, Bob also include a digital signature. And you know what is a digital signature? To prove to Alice that he is the true source of the message. To verify the signature, what Alice need? Alice need to obtain the Bob's public key, because public key in digital signature is used to verify the signature. And she can get this public key from a public key server or through email or any other mean. And then she can check the digital signature. In this manner, she makes sure that Bob, rather than someone else, placed the order. This all sounds good, okay, but suddenly we have another guy, the bad guy, the third guy, the Trudy in this case. He appears. And what happens? As shown in this figure, Trudy sends a message to Alice, in which Trudy says that actually Trudy is Bob. She pretends to be Bob. Trudy is actually female. So she pretends to be Bob and she sends a message to Alice, who is in the business, pizza business. Okay, so Trudy sent a message to Alice in which she claims that she is Bob, and she provide Bob's home address for delivery and order a pizza. Now in this message, the Trudy actually includes her public key because Alice need her public key. Although Alice naturally assume it is Bob public key. Okay, so Trudy also attach a digital signature which was created with her own private key. Now after receiving the message, Alice will apply the Trudy public key and she will be thinking that it is Bob public key. okay, to the digital signature, and concluded that the plain text message was indeed created by Bob. So what will she do? She will send the pizza to the Bob home, and Bob will be very surprised when the delivery person brings the pizza at his home because he never ordered it. The actual order was placed by Trudy by using her private key, and then she sent her public key towards Alice with the address of Bob, and then Alice believed that okay, the message arrived from Bob and not from Trudy or the third person, so she sent the pizza towards the Bob. Now this is a problem with the digital signature. This is actually the problem with the digital signature. How? We see from this example that for public key cryptography to be useful, you need to be able to verify that you have the actual public key of the entity with whom you want to communicate. In this case, Alice need to make sure that actually the order came placed from Bob and not from someone else. So you need a way to verify this or to solve this problem. When Alice wants to communicate with Bob using public key cryptography, she needs to verify that the public key that is supposed to be the Bob's is indeed Bob's public key and not Trudy public key. Now, building a public key or you can say like linking the public key to a particular entity. This could be done with the help of a CA, certifying authority or certificate authority. And this is what we are going to study. This is actually the public key digital certificate or simply digital certificate. So this was the problem with the digital signature. Message authentication, but user authentication is a problem. So that is why trust is an issue. And to solve this problem, we need the public key certification. And here is the broader view of the public key certification or how it works. Actually, you can see the process is very simple and similar to the digital signature, but we have an extra component, and that is the CA. So we have a user, for example, Bob, and we have a user, for example, Alice. This is the user who want to send a message towards the Alice. So Bob write the message. Now he want to sign the message. For that, he's not using the digital signature. He's actually using the digital certificate. Okay, what he need? He actually need the private key. Okay, private key. Bob will be using the private key to sign the message. And then at the receiver side, Alice need to verify whether the signature is valid or not. But what she need? She need the public key of Bob. But that public key is not directly sent by the Bob. Actually, this public key has been obtained from the certifying authority. What's happened here? We are using a certificate instead of using the digital. Instead of using the digital signature, we are actually using the certificate, and that certificate need to be verified with the certifying authority, with the CA. We have to present this certificate to the CA. Hey, check the identity of this user Bob, whether this message has been received from Bob or from someone else. So this is the role of the CA. In order to elaborate further the role of the CA, actually the CA has many responsibilities, but the primary responsibility is that CA actually verifies that an entity, for example in this case Bob, it could be another person, it could be a router, it could be a machine, it could be a node, it could be a computer, etc. Actually, the entity is who it says it is. When dealing with the certifying authority, one must trust the CA. So the verifier, the Alice in this case, she must trust on the CA. And as we just saw, CA could be a financial institution, could be a government agency, could be a third party broker, etc. But it is trustable. Means that the certificate issued by this certifying authority is something on which we can trust. Another property of this CA is once the CA verify the identity of the user, in this case the identity of the Bob, the CA creates a certificate that actually binds the public key of this entity to the identity. Means the public key of this user will be make strongly related with the identity of this user. The two things must be interrelated with one another. So the certificate contains the public key, and also I'm talking about this public certificate. It contains inside this certificate we have the public key of the entity. Okay, so the certificate contains the public key of the entity as well as a uniquely identifying information, the identity of this user. That must be unique. Okay, how it works, we will not go into the more technical details because there are certain fields in this certificate and how it works. But at an abstract level, things are like this. Okay, so if you want to solve this problem of the pizza prank, then you can actually use the certificate. How you can use it? Well, Trudy and other undesirable persons. So when Bob placed his order, he also sent his certificate, and that certificate is signed by a CA, or you can say that is provided by the CA. Once Alice received an order, she will use the CA, certifying authority, public key to check the validity of this certificate. She will check the validity of this certificate with the help of CA. Okay, whether this certificate is valid or not. And as I just mentioned, the certificate consists of public key as well as the identity. So if they matches, it means that the request is legitimate request and she can fulfill it. So with the help of a trusted third party like CA, we can make sure that who is who, or the identity of the person is actually that person and not someone else. There are different types of certificates available. The most common one is X.509, and the standardization organization like ITU, which stands for International Telecommunication Union, and IETF, which is International European Telecommunication Foundation, they have developed several standards for the certifying authorities. And X.509 certificates, that is one example, and it is used in the majority of applications like IP security, like SSL, like SET, like SMIME, like SSL, TLS, SET, etc. So many security related protocols, they actually use this certificate. And this certificate actually provides a framework for the provision of authentication services. Okay, and the standard actually does not recommend that which protocol you are actually using, but up to some extent they prefer to use RSA, which we will study in this course later on. And this certificate actually has certain fields. For example, what is the version, what the current version of this certificate. It has several fields. One of the field is version, another one is the certificate holders public key, like the CA has his public key, because if you want to to find or to verify the identity of a user or the public key of the user, you need to communicate with the CA, and for that you need the public key of the CA. So actually one of the field contain the public key of the certifying authority, and another field is like serial number, which is unique identity of the certificate, and also the certificate holder's name, who actually holds. What is the validity of this certificate? In most of the cases it's going to be 1 year, more than that. And also who is actually issuing that certificate, what is the digital signature of the issuer, identification of the issuer, and things like that. So plenty of things are there. So this was about digital certification. Thank you so much for watching the video. Take care and goodbye.